All right, so we just started by reviewing the formulas and reading the first question, and now we're finding D. Some of you can see it in your head. For me, it's not that easy, so I'm going to do the second term minus the first term to find D. 6,550 minus 6,800. I got negative 250. Anybody else get that?
Yeah.
Okay. Negative 250. And if you wanted to put a unit on it, you could put yen, which is kind of fun to draw there. Yen. All right, calculate the price of a ticket in the 16th row. So are we trying to find a term or a sum? I heard both answers.
Wait, I want to.
A term, right?
It's a term, right? Because it's just the value in the 16th row. If it said you want to buy the tickets in all of the first 16 rows, then that would be a sum. But we just want to find just the one ticket in the 16th row. So we're going to find the 16th term. So that's going to be A sub 16. Or U sub 16 if you prefer. And my formula is arithmetic. So it's this one. But again, I'm going to use the A's. So my first term is my A sub 1, and that's this one. Plus, what's my N? 16. And then times D, which we just found. Okay, remember on your TI calculator that there are different buttons for minus and negative. So this is minus, and this is negative. I want you to practice entering it because some people are still getting the wrong answer even though you have the right setup.
No, like, it's not over, like, because I've done that.
What are you guys getting?
30, 50, yeah.
Okay, 3,050 yen.
And like, I would get like and then we like bleach it, so like it would just like when I would have to bleach and then all the together. No, no.
Okay, find the total cost. Total means we're finding a what? A sum. We're finding a sum of buying 2 tickets in each of the first 16 rows. So we'll find the sum of the first 16 rows and then we'll multiply by what?
Wait, what?
We're going to find the sum of finding a ticket in the first 16 rows. And now we want 2, so we just multiply your answer by 2. All right. So the sum of 16 rows. I do not know. Oh, I do know the last row because I just found it. You see that? That's A sub 16. So I can use the easier formula. So the easier formula is this one when you know the first and the last. And so it's going to be 16 over 2. The first row plus the last row. And then after I get that answer, I'm going to want to multiply it by 2. What did I forget?
Wait. Where did you? Oh.
All right, so far I'm getting 78,800. Anybody confirm that? Good, thanks. And then because we want 2 tickets per row, then we're going to multiply by 2. All right, on the back we have another IB question. Here we go. Mia baked a very large apple pie that she cut into slices to share with her friends. The smallest slice is cut first, and the volume of each successive slice of pie forms a geometric sequence. That would be so hard to do. But maybe like some people, they have like a special slicer that would work. The second smallest slice has a volume of 30 cubic centimeters, and the fifth smallest slice has a volume of 240 cubic centimeters. And so it's going to take us a minute to find this R. It's not obvious. Let's put down the 5 spaces here. Okay. For the first term, the second term, the third, the fourth, and the fifth. And it says the second smallest slice is 30, and the fifth smallest slice is 240. And it tells you it's geometric, which means it's what kind of pattern? I heard one answer. Is it adding or multiplying? It's multiplying. So we have to multiply times R 1, 2, 3 times to get to 240.
Wait, what about the first one?
We don't know the first one either. But I know to get from 30 to 240, we have to multiply by R 3 times. So one way to write that is 30 equals R to the third, because that's 1, 2, 3. 30 times R to the third equals 240. So you start with 30, you multiply by R 3 times, and you end up with 240. So try to solve that, find out what R is, and then continue with the problem. You're reasoning it differently, and that's totally fine. You can reason it out any way you like. If you solve it algebraically, you're going to divide by 30 and get R cubed equals 8. And we have to solve that with a cube root. So let's find the cube root on the calculator. So press the math button right here. And then you'll see cube root is choice 4. And then you can do cube root of 8 to get the R is 2. Anybody else get R is 2?
Yeah.
Okay, good. All right, so when you get R cubed is 8, you do the cube root of both, cube root, and then you get R is 2. Find the volume of the smallest slice of pie. So if I'm multiplying to go to the right, what do I have to do to get to the left? You're going to divide. So you can just do 30 divided by 2 is 15, and it would be 15 cubic centimeters. Okay, the last one says the apple pie has a volume of 61,425 cubic centimeters. That is its total volume. So what kind of formula are we going to use here? If that's its total volume, am I going to be using the term or the sum formula? The sum. So I'm going to use the sum formula, and I actually know the sum, so it's going to get substituted for the sum. So let me pull the formula up. It's going to be geometric because it's multiplying. And so it's going to be S sub n equals A sub 1 times 1 minus R to the n over 1 minus R. And then substitute in A sub 1 we just found is how much? The first term is how much? 15. So 15. 1 minus, we found R right there. And we're trying to find n. We don't know n. And then 1 minus 2. Oh, and we know the sum. We know the sum is this number here. 61425. Okay. All right, what's 1 minus 2? Negative 1. The denominator here can become negative 1. We cannot do anything with this yet because this one has an exponent stuck on it. So I have 15 divided by negative 1, which makes what? Negative 15. So I'm going to combine those to make negative 15 times 1 minus 2 to the n equals this number.
So can you move the table?
Oh yeah. And then I'm going to divide by negative 15. Need to kind of make some space here. All right, next step, I'll divide that. 61425 divided by negative 15. 1 minus 2 to the n equals negative 4095. Okay, I'm going to get rid of this positive 1 by subtracting it. So I'm going to subtract 1. And I get negative 2 to the n equals negative 4096. Okay.
Wait.
Yes. All right, I want to solve this with a log, but you can't really do logs with negative numbers, so I'm going to divide both sides by negative 1 to turn them positive. So I get 2 to the n equals 4096. And if I, oh, you can't see that. And if I rewrite that with a log, it's log base 2 of 4096. All right, so now I need to remember how to find log base 2 on my calculator. I'm checking to see if it's in a catalog. It might be. You need log base, basically. Yep, okay. So on your TI, you can go to the catalog, which is going to be above 0. So you press second, 0. And it's in alphabetical order, so you need to go all the way down to log base. Okay, when you get to log base, press enter. And then you can do log base 2 of 4096. And you get 12. And that's it. All right.
This row there, like that one.
You may, but I would think it would be a better idea to wait until you finish 3. Charlie and Daniela began a fitness program. You can tell it's IB because the way they spell things, program. On day 1, they both ran 500 meters, and on each subsequent day, Charlie ran 100 meters more than the previous day, where Daniela increased her distance by 2% of the distance they ran on the previous day. So here's my first question. Which of these is arithmetic and which is geometric? Which one is adding each day? Charlie is adding each day, so Charlie is arithmetic. What Daniela is doing is Daniela is increasing by 2%, which multiplies by 102% each day, or 1.02. So Daniela is geometric. Okay, so we'll do Charlie's first. I think both of them started with 500 as their A sub 1, and then they had different things that they were doing. How much did he run on day 20? So we need to find A sub 20. And it's going to be the first term, 500, plus n minus 1 times d. And it says his d is 100. Okay, so he started at 500, and then plus n minus 1, because it says day 20, times 100. All right, so let's see how much this is. All right, so he's running 2,400 on day 20, which is like not that much, right? It's like between 1 and 2 miles. Not too much. All right, Daniela. So Daniela is geometric, so we're going to find a sub 20 for her. Still start with a sub 1 times r. So this time it says the r increases by 2%. So it's 100% plus 2% makes 102%. And remember that the word percent means per hundred. So if you do 102 divided by 100, you get the decimal, which is 1.02. So that is her R, 1.02. And then raised to the 20 minus 1. Your calculator does know order of operations, so you can put that all in the calculator at once. All right, Daniela is not running too much on day 20. Eventually, she'll be running a lot because exponential will grow quickly eventually. She just hasn't gotten to that yet. So she's doing about 728 kilometers. No, meters. Kilometers would be a lot. 728 meters. On day N of the fitness program, Daniela runs more than Charlie for the first time. Find the value of N. All right, this problem may be a little bit advanced for us, but what we're going to do is we're going to solve it graphically. So what we're going to do is we're going to put their equations in the calculator. So what I want you to do is go to your calculator. Let's find mine. Press your y equals and clear out what's in there. And we're going to put Charlie's equation in, so 500 plus, instead of 20, we need to put in x, because we don't know how many days it is, minus 1, and then times 100. So this is Charlie. We don't know how many days until they're the same. Let's go down to Daniela. Daniela's 500 times 1.02, and then raised to the x minus 1. Marley, you should be trying this on the calculator. All right. Now, if you press graph, we're going to see some, actually we're not going to see much because this graph doesn't really happen between -10 and 10. So what I think we're going to try is a zoom fit and see if that helps us. So once you have it, go to zoom. And we're going to go down to zoom fit, which is choice 0. Let's see how that works. Oh, that's not bad. All right, so right here where the lines cross,
Which one did you press?
I did zoom. And then I chose zoom fit, which is choice 0. Choice 0.
Failing to see.
You have to scroll. Zoom and then zoom fit. All right. Let me just double check my y equals because it's not looking super exponential. Nope, this one. Yeah, it's exponential. Okay. All right. Looking back at my graph, we want to know where these two cross. Here's your steps. Ready? Second. Trace. Second, trace, and then you're here. You good? Second trace. Now we want to know where they intersect. So you're going to press 5. And then you're going to press enter 3 times. 1, 2, 3. We did something wrong. And by we, I mean me. All right, we'll figure this out. Well, they started at 500, right? Oh, so what we want to know is when are they the same again? They both started at 500. Let me try making my window bigger. I need to make my X max, make it like 100. And I'm going to make my Y max 14,000. And I'm going to press graph. Oh, so you can see like how this one's going to come up there eventually. I just haven't gotten there yet. It's okay, guys. We'll do this together up front. We'll get there. All right. So I think I need to change my X max again to 200. No, let's do 1,000. Let's try again. Ooh, I'm getting closer. And then my Y max. I'm going to make my Y max 25,000. Okay. So up here, this is the intersection that we really want. This is a bit advanced. This is an IB question. So I'm going to show you second, trace, intersect. And then I'm going to press enter and enter, but then I'm going to go over to, why is it so, oh, that's not what I'm doing at all. All right. Well, those are the steps. Second, trace, intersect, and then you have to find where these cross right here. And we'll find that answer together later.